Hi Gators! So we are in our last lesson of this chapter. We're finishing out our discussions around area and perimeter. Today we're going to build off of what we talked about last time, which is that relationship between area and perimeter. So last time we looked at some rectangles that had the same perimeter but different areas, and we compared them to find which rectangles had the greater area when the perimeter remained the same. And one thing that we discussed was that if it has a very narrow width or side length, then the area is probably also going to be small. But if that width gets larger, less of those unit squares have their sides exposed to be counted in the perimeter. So the area can get bigger if the shape is wider. An area will get smaller if that shape is squatter. All right? Today we're going to look at some rectangles that have the same area but different perimeters. So I'm going to start with a question like we did last time. Two shapes have the same area. Does that mean they have the same perimeter? And that's not to say, last time we talked about area and perimeter are not always equal. They're seldom equal. They can be. What I'm more asking is a question about our park. So if we return to our parks, let's say that they are putting tarps on the grass at our park. And in my park, it takes them 10 tarps to cover the park. And Julie, my friend, it also took her 10 tarps to cover her park. And Joshua, it takes him 10 tarps to cover his park. So all of us have the same area of parks in this scenario. But will the perimeter of our parks be the same? Will my perimeter be the same as Julie's perimeter or Joshua's perimeter? Now remember, I'm talking a new situation, not returning to those same parks as last time. Let's find out. So I have two different parks or shapes here. I have one that's made up of combined rectangles, like we talked about a couple lessons ago, and one that's just a normal rectangular shape. So these are ones that I came up with. These are not out of our book. But you can see that I've counted the squares out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So both of them have 12 square units inside, which means they have areas of 12 units. Their areas are the same, but let's see if their perimeters are the same. So here I counted around and I found that it took me 16 units to get around this rectangle. Here it took me 26 to get around this combined rectangle. Now I could have made this one really long 12 unit rectangle that looked just like a regular, really skinny rectangle, and you would have found the same thing, which is that when we make the same number of squares but we make something really skinny, we're gonna get a much larger perimeter because so many more sides are showing of those squares. Here, all of these sides in the middle aren't being counted in the perimeter, but here we have so many sides exposed on these unit squares. They're all showing because the shape is so skinny, and so our perimeter is going to be a lot larger. Now this relates to what we were talking about last time. Last time we tried to keep the perimeter the same, and what we found is that we couldn't use the same, we wouldn't get the same areas if we did that. So if we took a wide rectangle and we flattened it, it took us a lot less squares to get to that perimeter that we were aiming for, right? So today is a similar concept. If you're forced to use the same number of squares, and you take the same number of squares in a wider shape, and you put those same number of squares in a really skinny shape, the wider shape is going to have a smaller perimeter because some of those sides are hidden on the inside of that shape. Versus when you have one of those long skinny shapes, you're counting a lot of those exposed sides, right? So in this case, our perimeter is going to get a lot bigger when we're forced to use the same number of unit squares. So I know this seems a little bit strange, but let's keep looking at it and I think you'll understand what I'm talking about today. So I went ahead and took our rectangle out of the book. This time it's a square. So this is a 3 unit by 3 unit square, and I've already solved for the area and perimeter. So our area is 3 units by 3 units, which is 9 square units, and our perimeter is 3 plus 3 plus 3 plus 3, which would be 12 units. So now's a great time to pause and follow along with me if you like. If you picked up your textbook, this page is in there for you if you want to open up to the correct lesson, or if you just want to follow along on a scratch piece of paper, that would be great as well. All right, so just like last time, they're gonna ask us to draw a rectangle. They're gonna say draw a rectangle that has the same area. So this time we're doing area is the same, not perimeter. That has the same area but a different perimeter. So if I look at this rectangle, this square, you're gonna notice that, is it a very skinny rectangle or is it a wider rectangle? Did they stack the rows? They stacked them, right? So again, if they showed me a stacked one, it's really easy for me to just go ahead and show them one that's very skinny and long. So I'm gonna take these 9 square units and I'm gonna lay them out in one very long rectangle, and that's just what I did. So I took my squares and I went 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, when we find the perimeter of this, I want you to predict. Do you think the perimeter is going to get higher because more sides are showing in this shape? Or do you think it's gonna get lower because less sides of our square units are showing? If you said that it's going to get higher, you are correct, because you can see that inside of this shape, there's a whole square that has sides not being counted. All these sides inside of our shape are not being counted, but here we have at least 2 sides on every single square that are being counted, if not 3 on those end squares. So let's go ahead and solve. So we know our area stayed the same. We know we used 9 square units to make this shape. Now we can solve for the perimeter by adding 1 plus 1 plus 9 units plus this 9 units. And that would make a 10 and a 10, which would get me to 20 units. So my perimeter went from 12 units all the way to 20 units. So which rectangle had the greatest perimeter and why? This very skinny rectangle that we drew had the greater perimeter because more sides of those unit squares are showing. In a wider shape, like the one that they provided, some of those sides are hidden on the inside of the shape. And so the perimeter is going to be smaller if the area is the same. All right, Gators? So let's look at some of the problems they're going to have you practice today. Like last time, they're going to give you 2 rectangles and they're going to ask you to compare them. But this time, instead of having the same perimeter, they're going to have, as you might guess, the same area. So this is a great moment to pause if you haven't done so already. Please go ahead and draw these shapes and practice along with me. Pause the video if at any time you feel like you want to go a little bit slower to check your work and count those squares inside. Please go ahead and do so. I'm going to hold this up so you can go ahead and pause here and write this out, and then I'm going to go ahead and start. So here are my shapes. They gave us 2 rectangles. This first rectangle, rectangle A, has a side length of 2 units and another side length of 2 units. So again, a rectangle can be a square, but a square cannot always be, or I'm sorry, a square is always a rectangle, but a rectangle is not always a square. All right, so 2 units by 2 units means that we can solve for our area. 2 times 2 is 4 square units, or units squared. And we can solve for our perimeter by adding together these 4 sides. So that would be 2 plus 2 plus 2 plus 2, which would be 2, 4, 6, 8. So our perimeter is 8 units. All right, now let's look at rectangle B. Rectangle B has a side length of 1 unit and it has a length of 4 units. So I'm gonna pause to predict really quick. I know my area is gonna stay the same because those are the problems they're giving me today. But do I think my perimeter is gonna get bigger, or do I think my perimeter is going to get smaller? I think it's gonna get bigger, and here's why. Again, we see that they've made a squatter, a less wide rectangle down here, one that's only 1 unit as compared to this one up here that's 2 units wide. All right, so let's check. So first I'll find my area. That's 1 times 4 in this case, which is still 4 square units. And I'm gonna go ahead and find my perimeter by adding 1 plus 1 and 1 plus 1 and 4 plus 4, which would be 5 and 5, which would equal 10 units. So quick check, 8 to 10, it did go up, right? So they're gonna ask me this time, which rectangle has the greater perimeter? So like we said, this skinnier rectangle has the greater perimeter, rectangle B has the greater perimeter. All right, last practice problem, go ahead and pause the video, Copy down the dimensions if you want so that you can follow along. I'm gonna go ahead and get started. So rectangle A here has a side length of 3 units and a length of 1, 2, 3, 4, 5, 6, 7, 8 units. Rectangle B is 4 units on this side and 1, 2, 3, 4, 5, 6 units along this side. So now I can solve. My area here would be 3 times 8, which would be 24 square units, or units squared. And then my perimeter will be 3 plus 8 plus 3 plus 8, which is the same as saying 11, plus 11, which would be 22 units. All right, now B is a 4 by 6, so I can find my area. 4 times 6 is going to equal 24 square units, so my area stayed the same. Now my perimeter is going to be 4 plus 6 plus 4 plus 6, so 4 plus 6 plus 4 plus 6, which is the same as 10 plus 10, which is 20 units. So in this case, the perimeter got smaller because we went from a shape that was less wide to a shape that was more wide. And remember, when we get more wide, that perimeter is going to go down. Even though it seems like it should go up, it's not going to, because some of those squares aren't being counted in the center, and more of those squares are being counted in a less wide shape or a skinnier shape. All right, so these are the kind of problems you're going to see today. I wish you the best of luck, Gators. Please go ahead and rewatch this video. If you have any questions, contact your teacher. We're happy to help you. Have a wonderful day. All right, friends, bye.